So here is a problem from a final practice exam, and it's asking us to basically part A, the function f of x equal to, here's the function given. Here's part A, and it's asking us first of all to find the domain. Domain is not too bad. Domain for exponential functions is just negative infinity and infinity. And then it's asking us to find the range. And here, for the range, we have to pay a little bit more attention. What we have in here is basically, let's graph this very quickly. So here, again, this is not a complete graph and it's not completely accurate, but as x goes to positive infinity, y approaches 7. So let's say 7 is about here. And then as e to the x, negative x, gets bigger and bigger toward the basically as x goes to negative infinity, as x goes to negative infinity, this value gets very large negative number, and so it starts from here and it goes like that. So this seems like we start from negative infinity for the y values and we end up at 7, but not exactly at 7. We get closer and closer to 7. So the answer is negative infinity and 7 with an open parentheses. And then the third one is asking find the x-intercept. For x-intercept, set y equal to 0. That means here f of x equal to 0. 0 is equal to negative 5 e to the power negative x plus 7. Now solve for x. So isolate the exponential, or take this one to the other side, so it becomes positive equal to 7. Then I have solve for the exponential, and then take the natural log of both sides. Natural log of 7/5. This side is just going to natural log and e are the reciprocal of each other, so I end up with this, which means that x equal to negative natural log of 7/5. Now this is just the x value for the x-intercept, and y value was, by the way, 7/5 is also 1.4, and 0 is the answer. The next part is asking, so now for part 4, let's find the y-intercept by setting x equal to 0. Setting x equal to 0 gives me y is equal to negative 5 e to the power 0 plus 7, and that is negative 5 because e is to 0 is 1, and that's 2. So 0 and 2 is the y-intercept. Now, what are the horizontal asymptotes? We accidentally actually solved that as x goes toward the over here. As x goes toward the positive infinity, e to the power negative x goes to 0, and therefore the entire thing approaches 7. So this is the horizontal asymptote. And the last part of part A is asking what are the vertical asymptotes, and there is no vertical asymptote for exponential functions, so none. let's continue with the second part of this problem. And here it's asking us to solve this equation with logarithmic equation. So with logarithmic equations, my goal is to basically combine until I can take a natural log and solve. Here, I can see I can combine these two, and I can get natural log of 7 minus x times x minus 3, because the sum of natural log is the natural log of the product of their arguments. And then here, let's see. Now I have natural log equal to natural log. So I can go exponential to exponential. And what ends up with, because exponential and natural log are a reciprocal of each other, I end up at this equation. Now that I'm at this equation, I can tell that I have a polynomial. Let's figure out what kind of polynomial I have. And the reason is that here it's factored, that way is not factored. I have to put them all together, then factor if needed. So multiplying it together, I get 7 times x minus 21 minus x squared plus 3x equal to 2x minus 9. And that is minus x squared plus 10x minus 21 equal to 2x minus 9. It is obviously quadratic, but not in the standard form. So write it in quadratic, subtract 2x, and then subtract minus 9 means add 9, and you get 9 plus minus 21, which is minus 12. Equal to 0. Let's see if we can factor this out. I mean, I like them this way better. And what are the two numbers that multiply? They multiply and becomes 12, and they add up to negative 8. And here it seems like 2 and 6 are the answers. So the answers that I got are x equal to 2 and x equal to 6. Now let's make sure that these are, because we did this combining and we could have added extraneous solutions. Let's see if that's the case. Let's try to plug in 2 back in here. If I plug in 2 in here, natural log of 5 plus natural log of negative 1. No, that's not possible. So this was the extraneous solution. And then try to plug in the other one to make sure at least one of them is the answer. And I plug in 6 and 6. Sorry, 6 in the wrong place. 6. So natural log of 1 times plus natural log of 6 minus 3 is 1. So we get, combining them together is natural log of 3, and on the other side is natural log of 12. If I plug in 6 in here, minus 9, which is natural log of 3. This actually worked, and this is the solution.